Hi students, welcome to physics classes. We are discussing about motion in a straight line. In that we discussed some terms related to kinematics. Now today class we will discuss about velocity and some forms of velocity. In the previous class we discussed about speed. Today we will discuss about velocity. Now here, before entering into the topic, in the previous class we discussed about speed. Now if a vehicle, for example a car, is moving with 10 meter per second. If a car is moving with 10 meter per second, means it is very clear that car is moving with 10 meters in 1 second. For 1 second car is moving 10 meters. For 1 second car is moving 10 meters. Now here we will get a doubt. Which direction car is moving? East or west, north, south, or going up a hill, or coming down the hill. Here if you say 10 meter per second, car is going with 10 meter per second, it is incomplete. When it will become complete, we should specify its direction. We should specify its direction. If you say car is going with 10 meter per second towards east, car is moving 10 meter per second towards east, then it is very clear, no? So instead of saying speed, we need another word to specify its direction, that is velocity. Velocity of the body can be found by dividing the displacement with the time taken. Velocity can be found by dividing displacement with the time taken. Now the difference between velocity and speed. Here velocity has specified direction. Velocity has specified direction. Displacement by time taken. In the speed, there is no specified direction. Distance by time taken. Okay. Now, as it is having direction, velocity is a vector quantity. Velocity is a vector quantity. Velocity has a specified direction. So, velocity is a vector quantity. Now, units. SI units. Displacement meter, time second, meter per second. CGS units, centimeter per second. SI units, meter per second. CGS unit, centimeter per second. Now types of velocity. As we discussed in speed, uniform speed, non-uniform speed, average speed, we have velocity also. Uniform velocity, non-uniform velocity, and average velocity, instantaneous velocity. If a car moving in a straight line in different situations, A to B, B to C, C to D, D to E. Now each one is 20 kilometers. Each one is 20 kilometers. Now time taken to travel also, each one is 1 hour. Now here body covered equal displacement. A to B displacement 20 kilometers 1 hour. B to C displacement 20 kilometers in 1 hour. C to D displacement 20 kilometers in 1 hour. D to E 20 kilometers in 1 hour. Now equal displacements in equal intervals of time. Equal displacements in equal intervals of time. Then the body is said to be traveling with uniform velocity. Uniform velocity. Here displacement, equal displacements in equal intervals of time. Equal displacements in equal intervals of time. Then the body is said to be traveling with uniform velocity. Now here, if a body traveling in a straight line path, Now here, when the body traveling in a straight line path, distance, displacement both are same. So here, instead of saying displacement, can we say distance in a specified direction? So we can write here equal distances in equal intervals of time in specified direction. Now if the body travel equal distances in equal intervals of time in specified direction, then the body is said to be moving with uniform velocity. Uniform velocity. Now non-uniform velocity. Now in previous case, distances in a specified direction are equal and times also equal, then we said it is uniform velocity. Now if the body covered different displacements in equal intervals of time or same displacements in different intervals of time, either different displacements in same time or same displacements in different times, then the velocity is said to be in non-uniform velocity. Velocity is non-uniform velocity. Means here in each time velocity of the body changing. Here 40 km per hour, here 30 km per hour, here 50 km per hour. So velocity of the body changing. Now coming here 40 km per hour, here 40 divided by 2, 20 km per hour, here 40 divided by 1.5, more than 20 km per hour. So velocity of the body changing. Velocity of the body changing, then it is said to be non-uniform velocity. Now average velocity. Now if a body traveled with uniform velocity, velocity of the body not changes. That's why it is also known as constant velocity. Here body continuously traveling with the same velocity. Velocity of the body not changing. So here average velocity is equal to its normal velocity, because velocity of the body is not changing. Velocity of the body is not changing. Total entire any situation it is traveling with the same uniform velocity. So velocity of the body not changing at any point. So its normal velocity becomes average velocity. But if the body traveled with non-uniform velocity, if a body traveled with non-uniform velocity, if a body traveled with non-uniform velocity, means continuously its velocity is changing. Continuously its velocity is changing. In these type of situations, to find average velocity, if the body traveled from different points S1, S2, S3 distances in a time T1, T2, T3. So average velocity equal to total displacement by total time taken. Total displacement by total time taken. So here we can write S1 plus S2 plus S3 by T1 plus T2 plus T3. Average velocity equal to total displacement by total time taken. This average velocity we can express in another form also. Now with respect to O, the object changes its position from x1 to x2 in a time t1 to t2. Time taken when it is at x1, time is t1. Now when it is reached to x2, time is t2. So change in position, average velocity equal to change in position by change in time. Change in position by change in time taken. Now change in position or change in displacement. Change in position or change in displacement by change in time. Now what is the change in position? Final position minus initial position. Final time minus initial time. So this can be represented delta x by delta t. Delta here change in displacement or change in position by change in time taken. Now if a body travel different displacements, for example delta x1, delta x2, delta x3 positions, in different times, delta t1, delta t2, delta t3. So average velocity here, net displacement divided by total time taken. Now as displacement is a vector, we can write net displacement vector. Now what is the displacement? Delta x1 plus delta x2 plus delta x3. Even you can take more, whatever they given, and so on, plus and so on, divided by delta t1 plus delta t2 plus delta t3 and so on. This is average velocity. These all are the different formulas for average velocity in different situations. Different formulas in the different situations. Based on the given data, we can use these in numericals. Now, instantaneous velocity. As we discussed the instantaneous speed, instantaneous velocity. Instantaneous velocity means velocity of the body in a particular instant of time. Velocity of the body in a particular instant of time. Then velocity, instantaneous velocity equal to limit delta t tends to 0, delta s bar displacement here by delta t, that is equal to velocity, that is equal to ds bar by dt. Now here magnitude of instantaneous speed is equal to instantaneous velocity. Okay, because speed has only magnitude, that's magnitude equal to magnitude of velocity, and its direction will be based on the situation. This is about velocity, uniform velocity, non-uniform velocity, average velocity and instantaneous velocity. Thank you for watching. Please subscribe for more updates.